For the past year and a half, developers have fought a fragmented integration mess. While custom local agent skills and Google's multi-agent A2A frameworks dominated last year's designs, Anthropic's Model Context Protocol, released 2 years ago, has steadily matured into the industry standard. Today, we contrast these two approaches. Does a mature MCP render custom agent skills obsolete, and where does Google's A2A fit into your stack? Rather than a recent novelty, MCP is now an established protocol. By separating integration logic from the LLM runtime over standard JSON RPC connections, it has allowed editors like Cursor and Claude Desktop to share database, search, and API connections out of the box. But as agent stacks evolved last year, developers realized that a standardized connection pipe doesn't solve every coordination challenge. Understanding the topology is critical. An MCP host, which is your AI application runtime, manages the communication. It connects to one or more MCP clients, which act as the active connectors. These clients communicate with local or remote MCP servers. The server exposes 3 core primitives: tools for executable actions, resources for contextual data, and prompts for reusable system templates. This separates model reasoning from integration execution. Let's break down these 3 primitives. Tools represent executable actions the model can call, like querying a database or executing a shell script. Resources are read-only data sources that feed raw files, Slack logs, or Git histories into the model's context window. Prompts are predefined templates that help guide the model's tone and instructions, standardizing behavior across different clients. Look at how a database MCP server is configured. Instead of writing custom database connectors for every single agent, you spin up a standard Postgres MCP server. The server exposes a read query tool. When the developer asks to analyze user signups, the client redirects the SQL generation to the local Postgres server via JSON RPC, keeping credentials and query logic abstracted away from the client codebase. The real power of MCP is multi-server composition. Imagine drafting release notes. A single client can query a GitHub MCP server to retrieve the commit log, query a Jira MCP server to pull resolved ticket details, and query a Slack MCP server to gather design feedback. The model acts as the central coordinator, pulling isolated context blocks from 3 different servers and merging them natively. This brings us to the architectural divide. Agent skills, introduced last year, are tightly coupled, local conventions and scripts designed to inject workspace rules directly into an agent's context. Meanwhile, Google's A2A protocol handles coordination between independent agent nodes. MCP, on the other hand, remains the universal transport layer for data. Think of MCP as the database pipe, skills as the local style guide, and A2A as the messaging network between distinct cognitive systems. But standardizing data connections opens a major security front. The OWASP GenAI Security Project recently released a practical guide warning about third-party MCP vulnerabilities. When a model connects to an external server, it exposes the local file system and network to new attack vectors. If an attacker compromises a public MCP server, they can hijack your agent to run malicious code on your host machine. OWASP highlights several critical vulnerabilities. The first is tool poisoning and rug pulls, where an attacker embeds malicious instructions inside tool descriptions, tricking the LLM into executing dangerous shell commands. The second is memory poisoning, which corrupts vector databases to bypass safety checks. Finally, tool interference occurs when execution loops across multiple servers trigger runaway API calls. Hardening your MCP connections is mandatory. For local servers connected via STDIO, enforce strict process sandboxing using Docker, Seccomp, or AppArmor to isolate file system access. For remote HTTP servers, implement OAuth 2.1 with OIDC and PKCE to enforce granular user-level authorization. Most importantly, enforce strict version pinning via tool checksum hashes and require human-in-the-loop approvals. The momentum behind MCP is undeniable. The open-source registry has exploded to hundreds of pre-built community servers, offering 100% portability between editors like Cursor, Zed, and VS Code. Bypassing local database configurations and custom API wrappers means developers can stand up a secure, multi-data coding environment in minutes, rather than days. The verdict is clear. MCP is the future of AI data and API integration, not coordination. While local agent skills define custom workspace-style rules and Google's A2A coordinates node-to-node dialogue, MCP is the standardized pipe that connects your models to raw files and databases. Secure your connections, pin your versions, and stop rebuilding database adapters. Let's build on standard pipes.